Assalamualaikum and good morning to my name Lima. My name is Nur Fatihah binti Kamal Effendi. Today I want to present about alkenes compound. So what is alkenes? Alkenes are the common family of hydrocarbons found in the crude oil. Here there is at least one carbon-carbon double bond. This double bonds differs to the chemistry of the compounds of the family. So the alkenes and particularly ethene are tremendously important in the chemical industry. They are not found in crude oil in a very large quantities but are produced by the cracking of the alkenes. The alkenes like all the hydrocarbons from burn in air to form carbon dioxide and water. So in oxygen, ethene reacts explosively, so it is not much good as a fuel. The alkenes are too useful in the chemical industry for the manufacture of plastics and many other chemicals to be used as fuels. So there are several uses of alkenes here, which including manufacture of plastics like polyethylene, manufacture of polystyrene used in making car battery or parts of refrigerator, manufacture of ethanol and synthetic fiber terylene, manufacture of acrylic fibers, making an antenna for car engines, and manufacture of propanol used in making acetone. So this mind map shows the physical properties of alkenes. So alkenes contains a carbon-carbon double bond which change the physical properties of alkenes. In general, for the physical state of alkenes, it is a colorless and odorless in nature, except ethene, as it is a colorless gas with a faintly sweet odor. The first attributed alkenes are gases, and the next 14 members are liquid, and the remaining alkenes are in solids. So for boiling points, the boiling alkenes have low boiling and melting points. The boiling point of the compounds increases as the number of carbon atoms increases. The boiling point of straight chain alkenes is more than balanced chain alkenes. For melting point, the melting point of these double bonded compounds depend upon the positioning of the molecules. Multipoint alkenes is similar to alkenes. However, cis isomer molecules have a lower melting point than trans isomer as the molecules are packed in a U bending shape. For density, alkenes has less dense than water. So next, in terms of solubility, alkenes is completely soluble in organic solvents or non-polar solvents such as benzene, but it is insoluble in water due to their non-polar characteristics. So the last one is polarity. Alkenes are weakly polar just like alkenes, but are slightly more reactive than alkenes due to the presence of the double bond. The pi electron which make up the double bonds can easily be removed or added as they are weakly held. Hence, the dipole moments exhibited by alkenes are more than alkenes. So alkenes display a weak dipole-dipole interactions. So next, we look at the reactions of alkenes. So alkenes are very useful compounds as they can undergo many types of reactions and they can therefore be used as starting molecules when making new compounds. So alkenes are hydrocarbons that contain one or more double bonds. So a sigma bond and a pi bond make up their double bonds. Side by side overlapping results in the formation of the carbon-carbon bond, and it is highly reactive and rather weak. The carbon atoms are also electron rich due to the pi electrons, which attracts an electrophile. Alkenes can therefore experience a wide range of equations, a wide range of substances, including halides, alcohols, ethers, can be produced using alkenes. So first of all, let's take a look at the addition reactions. So in addition reaction, it involves the addition of two atoms to the molecule or compound. One pi bond gets converted to two sigma bond during the addition reaction attaching to the incoming atoms. So electrophilic addition is the addition reaction of an electrophile to a double bond. The carbon-carbon double bond is broken and a new single bond is formed. So there are five types of addition reactions that I will explain more in these videos, which is hydrogenation, halogenation, hydrohalogenation, hydration, and polymerization. However, before that, we look first at Markovnikov rules and anti-Markovnikov rules. So for Markovnikov rules explains that in reactions of alkenes, the proton is added to the carbon atom that has the greatest number of hydrogen atoms attached to it, which means hydrogen atom attached to the carbon atom with the highest number of hydrogen substituents. So usually the protons are the hydrogen atoms who attach to the carbon atom that has the highest number of hydrogen atom attached to it. The counter ion is attached to the other carbon atom, so the end product will be alkane. So this occurs as a result of the reaction's most stable carbocation forming as an intermediate. Um, so the double bond is broken when the hydrogen atom is added to the carbon atom. The other vinyl carbon atom now has a positive charge as an outcome. To create a stable product at the end, this carbocation needs to be stable. So um, at the end of the reactions, there are mixture of products produced composed of the product given by the stable carbocation and the unstable carbocation. So in these Markovnikov rules, the examples of reactions under this rule is hydrogenation, hydrohalogenation, and halogenation. So for the opposite of Markovnikov rules is anti-Markovnikov rules. Anti-Markovnikov rules explains that in addition reactions of alkenes, the proton is added to the carbon atom that has the least number of hydrogen atom attached to each, which means hydrogen atom attached to the carbon atom with the least number of hydrogen substituents. So this mechanism does not involve the formation of the carbocation intermediate like Markovnikov rules. Chemical reactions can be made into reactions that give to anti-Markovnikov product by adding a peroxide such as HOOH to the reaction mixture. Here, the peroxide effect takes place. A peroxide can change the radioselectivity of an addition reactions. Radioselectivity is the formation of a bond at a particular atom overall other possible atoms. Therefore, the peroxide act as a catalyst. So there's only one reactions under anti-Markovnikov rules in addition reactions, which is hydration of alkenes. So now let me explain about the type of addition reactions. So first is hydrogenation reactions. So hydrogenation is the addition of hydrogen to the pi bond of alkenes to produce an alkene. So the reactions must be catalyzed by metals such as nickel or platinums. So one of the example of the reactions can be made by when ethene react with hydrogen in the presence of nickel, it can produce an ethane. So next is halogenation. So in halogenation, alkenes react with halide such as chloride and bromide at room temperature in the presence of tetrachloromethane CCl4. Halide gets attached to the alkene, breaking the double bond between the carbon atoms. And in this reaction, no catalyst or ultraviolet needed. So the example of these reactions can be made when ethene react with chlorine and it can produce dichloroethane. So next we move to hydrohalogenation. So here the double bond between carbon atoms breaks followed by the electrophilic addition of a hydrogen atom and halogen. According to the Markovnikov rules, the halide gets attached to the most substituted carbon. So the resultant product is a haloalkane or can be also alkyl halide. So hydrogen halide can be between hydrogen chloride or hydrogen fluoride or hydrogen iodide can is are one of the example for hydrogen halides. So one of the example of hydrohalogenation reactions is when ethene reacts with hydrogen bromide will produce bromoethene or ethyl bromide. So next we look at the hydration. So hydrogen is occurs when alkenes react with water. So alkenes react with steam water at 300 degrees and 60 atm in the presence of concentrated sulfuric acid H2SO4 or phosphorus acid H3PO4 to produce alcohol. So in this reaction, the pi bond of alkenes and hydroxyl bond in water breaks, producing alcohol. So one of the example in hydrogen reaction is when ethene reacts with water in the presence of phosphoric acid and in 300 degrees and 60 atm will produce ethanol. So the last one is polymerization. In this reaction, an alkene reacts with itself to form a high molecular weight compounds composed of repeating units of the original compounds. So here, the alkene acts as a monomer, producing polymer by joining its repeated units to give a single product. So for example, during polymerization of ethene, thousands of ethene molecules join together to make a polyethene. So that's for the type of reaction in addition reactions. Now we look at the oxidation reactions. So alkenes can also be oxidized by acidified potassium manganate, KMnNO4, which is a very powerful oxidizing agent. Alkenes can be oxidized by both hot and cold potassium manganate, and which it can result in different products. So when alkenes are shaken with cold dilute potassium manganate, the paper solutions will turn colorless and the product is diol. However, when alkenes react with hot concentrated potassium manganate, the conditions are harsher, causing the carbon-carbon double bond to completely break. So the reactions, if the alkenes with hot concentrated potassium manganate can be used to determine the position of the double bond in larger alkenes. So if a carbon atom is bonded to two hydrogen atoms, oxidation to carbon dioxide takes place. When carbon atom is bonded to one hydrogen atom and one alkyl group, oxidation to carboxylic acid takes place. And when carbon atom is bonded to two alkyl groups, oxidation to ketone will take place. So that's the difference that occurs in oxidation reactions. So the last one, we look at the ozonolysis reaction. So ozonolysis reaction is the oxidation of alkenes by ozone. Here, both sigma and pi bonds of the alkenes got destructed. So ozone has a dipolar ion structure which first adds to the pi bond of alkenes to form a highly unstable molozonide structure and then gets rearranged to another structure by breaking of carbon-carbon sigma bond to give ozonide. It is further cleaved under a reductive atmosphere using zinc dust or water to form corresponding carbon compounds like aldehydes and ketone. This oxidative cleavage of an alkene double bond generally accomplish a good yield. So, for example, when ethene undergoes ozonolysis, it will yielding two molecules of formaldehyde. So, and ozonide is formed as an intermediate product. In the presence of zinc dust and water, the ozonide gets transformed into formaldehyde. So the ozonolysis reaction is often used to find the position of the double bond in an alkene molecules. For example, the isomers of butane, two butene and one butenes can be distinguished via oxidative cleavage. By identifying the products, one isomer can be distinguished from another, and the position of the bonds in the original compound can be determined. So that's the explanation about ozonolysis reactions for alkyds. So there are also other reactions in alkenes, and I will only explain a little bit about these three reactions. So the first one is oxymercuration, the demercuration. So in this reaction, an alkene will react with mercuric acid in the presence of an oxygen nucleophile like water and alcohol to form an organomercury intermediate such as ethoxymercurial compounds. For the next one for hydrocarburation oxidation. So hydroboration is an oxidation reaction in which alkenes transforms into alcohol by reacting with water. It has two steps reactions. So in the first step, diborane B2H6 is added to form three alkyl boranes. So the reaction then proceeds in an anti-Markovnikov manner. So the last one is dehydrosilation. Dehydrosilation is when alkene is converted into a vinyl diol. The most common in and direct process for this oxidation is using a high oxidation state transition metal, typically like osmium or manganese. So that's for reactions in alkenes. Now we move to unsaturation test for alkenes. So these unsaturation tests are used to determine the presence of carbon-carbon double bond and to distinguish between alkene and alkene. So there are two tests that I will explain, which is the Bayer's test and bromine test. The first one is Bayer's test. For Bayer's test, it is a required Bayer's reagent, which is an alkaline solution of cool acidified potassium manganate, and it is a potent oxidizing agent and is used in qualitative organic analysis to test for the presence of unsaturation. So this is the examples of Bayer's reagent test. So for the left one is the general equation for the test. So here we can see that when alkenes reacts with potassium permanganate, which have a pinkish purple color, and also reacts with what add with water, it will produce 1,2-diol and manganese dioxide and potassium manganate. So the pink purple color of potassium permanganate disappears when an alkene, um, when an alkaline KMnO4 is added to an unsaturated hydrocarbon. The disappearance of pink color may take place with or without the formation of brown precipitate of manganese oxide. So here, for overall, the alkene is oxidized to 1,2-diol, while the permanganate is reduced to manganese oxides. The right equation is the example where for of alkenes, which is ethylene. So here we can look when ethylene reacts with potassium permanganate and water, it will produce ethylene glycol, manganese dioxide, and potassium manganate. So the left picture shows the positive results of and negative results for various reagents. So the left test tube shows the negative results where the solution remains pinkish pupils, which shows that an alkene or alkenes are absent. And the right test tube shows the positive result where the solution discharge color and a brown sludge is formed. So it shows the alkene is is present. So in overall, in various tests, the positive result um, achieved when the decolorization of pink color of KMnO4 indicates unsaturation. So this reaction is significant because it does not work on alkanes or aromatic compounds, and hence it can be used to distinguish from alkenes So the next one, we move back to bromine test. So for bromine test, it is used to test for an unsaturated carbon-carbon bond like alkene. So the test uses a type of a chemical reaction called addition, where a reactant is bromine, and it is added to an organic compound to break a double or triple bonds. The bromine solution is brown, and in this test, when bromine solution is added to the unsaturated hydrocarbon, the brown color will disappear. And in this reaction, the hydrocarbon must be unsaturated. So the bromine forms an addition product. So for overall, the positive result is achieved when the decolorization of orange red color of bromine solution indicates unsaturation. So here, the right picture, we can show that there are three test tubes, which the first one, which is the left one, is the just chemical sample. The middle one show the saturated with air, which is no double bonds, and showed that there is no alkene in this test tube because the bromine color is still there and just remains unchanged. While the right test tube showed that there is unsaturated hydrocarbon in that test tube and shows that alkene is present because the bromine solution is turns to colorless. So that's it for unsaturation test for alkenes. Okay, so this is the reference where I get all the information and research that I'm doing for this presentation. So that's all from me. Thank you.